So here we're going to continue with what we were doing. Number 9, they want you to continue to distribute. I can do this. They both have A in common. So A out here times 4 minus, don't forget the shadow 1, 1. That's A times 3, or 3A. And again, I can look at this and use logic and say if I have 4 A's and I take away 1 A, I will have 3 A's. Here we're going to combine like terms, and this is an important part of the general housekeeping involved in algebra. Make it easy on yourself and look for things that are alike to deal with first. So the first thing I'm going to look for is things that match. So here's 3x, and here's negative 4x, and here's positive 2 and positive 1. So let's see, 3x minus 4x, different signs, find the difference. That'll be negative x, negative 1x. And as I mentioned in class the other day, for now, and only for now, if you need to write a 1 here to help you keep track of it, that's okay for now. These are training wheels. But I'm going to tell you when you get onto your next math course, your teacher's going to say, I can't believe that they let you do that. I'm going to let you do it. Anyway, so negative x plus 2 plus 1 makes plus 3. So this expression now is negative x plus 3. I simplified it by combining like terms. Here I'm going to do another simplification exercise. What you need to do first is handle multiplication, because you have multiplication going on here and you have addition here. So let's take care of this first. I'm going to distribute this. 8 times 2y is 16y. 8 times 4, or positive 4, is positive 32. And then this just comes down, plus 3y. Now I'm going to look for things that match, and I have a 3y here and a 16y here. 16 plus 3 is 19y plus 32. And that is this simplified. And again, there's no equal sign, it's still just an expression. Let's do this again. Here I have two different factors. That's a piece of a multiplication problem, remember. So I'm going to distribute 2 times x is 2x. 2 times positive 3 is positive 6. Plus 4 times x is 4x. 4 times positive 2 is positive 8. Now I want to look for things that match, and I can do this because I have an addition sign here, so this is just one big addition problem. There's 4x, there's 2x, that gives me 6x, and here's positive 6 and positive 8, that gives me positive 14. The last thing on this particular paper is they want you to evaluate when x equals 5. This is an important vocabulary word in our math, evaluate. That means take this number and plug it in wherever you see an x. So here's my x, and instead of that I'm going to put in 5. So negative 4 times 5 plus 1. Negative 4 times positive 5 is negative 20 plus 1. Combine those and I have negative 19. One thing to think about with these evaluation problems is it sort of gives you an idea about why we call it a variable, because for this particular case x equals 5. But if I had a different case where x equals 10, I would have negative 4, and I would plug in, instead of x, I would plug in 10. So I'd have negative 40 plus 1, And my answer, if x equaled 10, would be negative 39. Here, when x equals 5, the answer is negative 19. So you can see that as x varies, the answer varies. As x changes, the answer changes. And that's why we call them variables. And here's a good example of why variables are so handy. In this case, we are asked to find the perimeter of this problem. I'm getting there. And we have a rectangle has one side that is x plus 4, so an unknown number plus 4, and the width is 6. And one thing I want you to remember with this is that sometimes people lose track of this when we do perimeter, but if we're working with perimeter, this side would be x plus 4 and this side would be 6. To go around the block, you go all the way. But here we are writing two equivalent expressions for the area of this figure. And what they want us to do is start with area. Remember, the area of a rectangle is the measurement of the length times the measurement of the width. And in algebra land, we write those letters right next to each other. That tells me length times width. So if this is the length and this is the width, we could write this as area equals this side times this side. So here's x plus 4 times 6. There's the length, there's the width. Now, I could also continue to write this out and distribute it, and I would have 6 times 4 is 24, and 6 times x is 6x. These two expressions are equivalent. That means that they are equal. You can see that I went from here to here, and by the same idea I could go from here to here. So those are equivalent. And again, because I do not know what x is, I can't tell you what the actual area is at this point. But you can see that as this gets bigger, the area would get bigger. They have a constant relationship. And that is the end of the problems for 10.1, Day 1, Unit 3.